Hello, hi everyone, this is Ganesh, and in this video I am going to solve a few problems from trigonometric identities. So these problems are related to trigonometric identities. Yes, most of the students are feeling difficult to solve these kind of problems, and in this video I'll solve a few problems. Easily you can understand how to solve all these things. First you have to remember the trigonometric identities, like nearly three identities are there. Generally the sine square plus cos square equal to 1, and one more identity, secant square minus tan square equal to 1, and cosecant square minus cot square equal to 1. And even in these particular problems we can use the reciprocals of the trigonometric ratios also. Yes, all these things will discuss a few problems. Easily you are going to solve these kind of problems. Yes, before going to solve this, please remember to subscribe this channel, and if you like this video, press the like buttons and give good comments and share these videos to your friends. Let us see the problem for 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. So in these kind of expressions in the given problem, other than sine and cos remaining ratios, we all know that total 6 ratios are there. So other than sine and cos remaining any kind of ratios are there in the given expression, first we have to write those expressions in terms of sine and cos. So try to write in that form. For example, you see here 1 plus tan theta is there, 1 plus tan theta plus secant theta. So we can write that 1 plus tan theta we can write sine theta by cos theta plus, and secant theta we can write 1 by cos theta. So these are all, we all know that already. Tan we can write sine by cos, and secant is the reciprocal of cos, the reason 1 by cos. And also these are also 1 plus cot theta we can write cos theta by sine theta, and minus, so cosecant theta we can write 1 by sine theta. So whenever these kind of problems are there, just simply convert this tan, secant or cosecant cot into in terms of sine and cos. So that will be easy, because sine and cos are easiest ratios, and coming to tan, secant, cot, cosecant, these are all complex ratios. So if we convert the expression in terms of sine and cos, easily we can solve it. So finally evaluate this problem. If you want to evaluate, finally we may get one number, or otherwise some proofs also there show that such kind of problems also there. Let us see here, evaluate there or simplify. So finally we need one number. Any number will get you an answer. So how do we get it? Let us simplify this. First, if I take the LCM of the first expression, what is the LCM? That is cos theta, and here we can write cos theta plus, because if we multiply these two we get cos theta, and here already sin theta plus 1, and also this expression again. Here what is the LCM? Sin theta, and here you write sin theta plus cos theta minus 1. And the next step is, if I consider cos theta plus sin theta, and sin theta plus cos theta is A, and this is B, this one is B. That means it is in the form of A plus B, A minus B. So A plus B into A minus B is equal to A square minus B square. We have an identity. If we write in that form, then I'll get sin theta plus cos theta A square. This is A square minus B square is 1 square. Then if I multiply these two, sin theta into cos theta. So in this way we can write it. Here I have used this identity, A plus B into A minus B is equal to A square minus B square. Used this identity, based on that we can write like this. After this, then I can write, if I write in this form, for example, it is in the form of a plus b whole square. So according to that, a square plus b square plus 2ab, in that way I can write it. So the reason, sine square theta plus cos square theta plus 2ab, that means 2 sine theta cos theta minus 1 square is 1 divided by, I'll get sine theta into cos theta. And after this, and here I can use an identity, that is sine square plus cos square is equal to 1. Sine square theta plus cos square theta equal to 1 plus 2 sine theta cos theta minus 1 by sine theta cos theta. After this, I can cancel minus 1 plus 1, and I'll get 2 sine theta cos theta by sine theta cos theta. But here these two and these two gets cancelled. Finally I got 2 is the answer. So in this way we can evaluate, we can simplify these kind of problems easily by using identities. You see, exactly whenever these kind of problems are there, the tan, quarter, first convert into, write into sine or cos, then easily we can solve in this manner. Here another problem, here secant square theta minus 1 into cosecant square theta minus 1. This is the expression. Just the question may be simplify the following or evaluate the following. So evaluate the following. Yes, you see the ratio secant and cosecant. I told you that the technique is the secant or cosecant convert into sine or cos. So secant square theta I can write 1 by cosecant 1 by cos square theta, 1 by cos, because cos and secant each other reciprocals. So secant square I can write 1 by cos square theta. So minus 1, and another one is cosecant square I can write 1 by sine square theta minus 1. Then here take the LCM. So then I'll get 1 minus these two multiplied, I'll get cos square theta by cos square theta, and even I can take the LCM, 1 minus sine square theta by sine square theta. So after this, here you see 1 minus cos square theta equal to sine square theta. Why? Because we all know that sine plus cos, sine square plus cos square theta equal to 1. So if I send cos square that side, then sine square theta equal to 1 minus cos square theta. So 1 minus cos square, in the place of 1 minus cos square I can substitute sine square. The reason I can write sine square here, and then this is sine square by cos square theta into, here again 1 minus sine square theta equal to again cos square theta divided by sine square theta. And now we can cancel sine square theta and sine square, and cos square into cos square. Finally I got that answer 1. So in this way, here also we are using that identity, that is sine square theta plus cos square theta is equal to 1. So using that identity we can simplify these kind of problems. And this is another problem. You see, show that 1 minus tan square a by cot square a minus 1 is equal to tan square. So we have to prove these two are equal. So RHS and LHS parts are there. In this time we can select any one of RHS and LHS, and we have to show that the another side. So I'll take this side, and finally I have to prove tan square a. So I'll take left hand side expression, that is 1 minus tan square a by cot square a minus 1. So after this I can write this in the form of 1 minus I told you tan or cot ratios we can converting into sine or cos. So tan I can write sine by cos, that means sine square a by cos square a divided by, and here I can write in the place of cot cos square a by sine square a minus 1. Now I'll take the LCM for this. So if I take the LCM of 1 minus sine square by cos square a, so if I multiply these two, I'll get cos square a minus sine square a divided by cos square a, and instead of this I'll put the symbol, and again I'll take the LCM of these two, again cos square a minus sine square a divided by sine square a. So if I want to divide these two, I'll remove this division symbol, then I can write cos square a minus sine square a by cos square a. So into, so if we change these two symbols, then what happened, the second fraction becomes the reciprocal. So I can write sine square a by cos square a minus sine square a. Then you see we can observe this one and this one, both expressions are same, cos square minus sine a and cos square minus sine both gets cancelled. Finally we got sine square a by cos square a, but sine by cos equal to tan square a, so tan square a. So this is the result we got it. So here you see how we are using this in normal simplifications. We have to remember the simplifications properly. Easily we can solve these kind of problems using. And hope you understand well these kind of problems. And if you like this video, don't forget, please share this video and like this video, and thank you very much.